most people seem to find mystical things rather than scientific things more attractive. And I don't think scientists are actually, in general, immune from this. A few examples is that the finite mass of a black hole is concentrated in zero volume, infinite density, and infinite gravity. Proponents of black holes believe them, they see them everywhere, just like people who believe in ghosts see ghosts working everywhere in mysterious ways. So when their mathematics tells them something, they get all excited and let the natural inclination to mysticism take over. Go to the original sources and analyze them, because otherwise you will find that you are just accepting things that are dogmatic. And dogmatism is the death of science.
Oh, looking sharp. I like that suit, sir.
Thank you very much. You're looking pretty sharp yourselves.
We're underdressed for the occasion. I'm sorry.
That's all right. Don't worry.
How are things on Earth?
Oh, they're going along okay. It's a bit wild down here, I must say, but nonetheless, we persevere and do the best we can.
Have you had any mouse plagues?
Yes. Well, not like in New South Wales, which has got a very bad one, but winter's starting here, and I'm in the countryside, and I've already trapped 10 mice in my larder. So usually I catch between 10 and 17. 17 is my record over a winter period.
Wow.
Whoa. What do you do with them?
I put them in the rubbish tin.
I hoped you were going to eat them.
No, not me. No, my palate's a little more fickle than that.
A little more sophisticated. All right.
Sounds like you need a cat.
Yes, but I do have a dog. But she doesn't chase the rabbits. That we have rabbits here as well. That's an introduced animal here, and it does cause a bit of havoc. But she chases some rabbits. But mice, they're too small for her to bother with.
So, Steve, you are the head of quality control at Mathematical Physics on Earth, from what we understand.
Well, that's a title that I haven't heard before, but I think that's possibly got some truth to it, yes.
So, what is it about mathematical physics that drew your interest originally?
Good question. I began investigating some esoteric theories in physics, particularly relativity, Einstein's theory of relativity. And I discovered that fairly quickly that the textbooks and the scientific papers that talked about things called black holes had some mathematical anomalies. So I investigated this carefully and discovered that the mathematical structure of the black hole theory is actually a violation of the rules of pure mathematics, to my astonishment. So I found that that can't be right. And further investigation revealed that there were much more widespread errors in mathematics within the whole theory of relativity, that's special relativity and general relativity. But I came at it from a point of view of general relativity, working backwards to special relativity, because it was the black hole that first piqued my interest. And I'd never taken this theory of black holes seriously on account of the very strange and I think quite nonsensical physical properties of black holes. And if I might just give a few examples, is that
yes, please.
According to of black holes, the finite mass of a black hole is concentrated in zero volume, infinite density, and infinite gravity.
And that's pretty much the definition of a black hole, or?
Well, in part, there are a number of things, but that's what the proponents of these theories maintain is the physical characteristic of the mass of the black hole. Outside the mass of the black hole, there is a thing called the event horizon, and it is intimately related to the mass, because if you increase the mass, you increase the radius of the event horizon. So this mysterious space element grows with the increase of the mass, and the mass grows if things fall into it, whether it's a car or a planet or a star or light.
Right. So this is sort of the radius at which the model begins of the black hole. Is that correct?
This is the physical ideas that come into it, but originally these were determined after the mathematics was all worked out, and the first instance of this black hole type business was produced in 1916 by the German mathematician David Hilbert, who it turns out made a monumental blunder in mathematics.
And how did he happen upon the black hole in the first place?
How
did Hilbert come across it?
Hilbert.
Where did the idea originate?
Well, he didn't give it a name, a black hole, but that came later. But the mathematical idea was that in his mathematical manipulations, he maintained that there was a certain interior of what's called a manifold. And this is a modification of the solution to Einstein's field equations by Carl Schwarzschild in 1916. Actually, he did it in 1915, right at the end of 1915. It was published in 1916. And Hilbert thought he would produce a more sophisticated derivation because he was a mathematician and Schwarzschild was an astronomer. But Schwarzschild's mathematics was quite impeccable. And given the field equations, Schwarzschild obtained a consistent solution. And his solution forbids black holes. There is no black hole in the Schwarzschild solution. And what you see in the textbooks is not Schwarzschild's solution at all. It's Hilbert's solution, and it's attributed to Schwarzschild. And you never see almost never see Schwarzschild solution in any of the literature.
So if I can just recap this real quick, Einstein's field equations basically laid out a framework for how the physical universe should operate, a basic set of relationships between objects, as far as I can tell. And this black hole concept represents a breakdown of those rules?
Well, it's a mathematical faux pas. So in other words, general relativity doesn't in fact predict black holes at all.
I see.
The black hole construct does come from the field equations by means of a mathematical error. So it's attributed to Einstein's field equations as being a consequence, but in reality, it's not so.
So it's not even that there's a breakdown of these laws, it's just that you believe there's been a mistake made that led to this interpretation that there's a breakdown of the laws.
Yes. Now, since it's a mathematical question, it's a question of mathematical proof. So it's not a belief. The belief side of things is resonant with the proponents of black holes because they believe them. So they believe them. They see them everywhere, just like people who believe in ghosts see ghosts working everywhere in mysterious ways. So astronomers look through their telescopes and they see black holes in mysterious ways because they believe in them, not because they understand the mathematical derivations.
And so when the first black holes were described, did scientists look out into the heavens and pinpoint where they could see them, or did they come later?
No, they came later. This is a very strange situation because rather than having an observation of something and then trying to describe it in terms of the laws of physics, this is the reverse. We have some strange theory that's supposedly to predict something by a mathematical error, and then the astronomers go looking for it and claim that they found them. So this is a matter of belief because if it's due to a mathematical error, and it doesn't exist. So it's a matter of belief.
So the prediction that they should exist came from a misinterpretation of the mathematics, is your idea?
It came from an error in mathematics. So you can misinterpret something even though the mathematics might be sound and you've had an idea about it and misinterpreted. This is actually due to a major error in mathematics.
I see.
And I illustrated this in my papers.
So can you just sort of simply break down some of the first errors that you came across in your sort of detective work about this problem that sort of tipped you off that something wasn't right?
Yes, well, I was fortunate enough to come across Schwarzschild's actual paper in an English translation, and I studied that very carefully and found that there is no black hole permissible by this solution. So I wondered why it was attributed to Schwarzschild. And that led me, of course, to the alternative derivation by David Hilbert, who introduced this mathematical error without realizing what he did. And ever since then, the proponents of black holes have relied upon Hilbert's solution, so-called solution, rather than Schwarzschild's solution, incorrectly named it Schwarzschild solution, and then developed this further. So they have a very elaborate mathematical structure resting on a bed of sand.
Did Schwarzschild and Hilbert know each other?
That's a good question. I don't know the answer to that. Schwarzschild was in the German army at the time, and he was on the Russian front. And
yikes!
He solved this whilst he was in bed, suffering from a fatal disease that he contracted whilst there, a skin disease. He actually wrote two papers. One was on the solution for Einstein's field equations in the absence of matter, and the other one was for a sphere of incompressible fluid. And neither of them have any physical meaning, but they were mathematical derivations that he obtained on the basis of Einstein's theory, taking it at face value. So his mathematical solutions are consistent with these Einstein's field equations, but they don't produce black holes in any way, shape, or form. So it was Hilbert's error that produced this, and that produced what we will call the interior of the black hole. That is the strange region below the event horizon, because this is supposedly an extension to the manifold, and Hilbert did this, and that was a mistake by Hilbert.
How did that mistake come to be? How did Hilbert make that mistake? Is there a way you can simplify that for our listeners?
It's a bit difficult to say that without actually writing some things out, but what he did was...
And they can check, by the way, everybody can check out your papers. We'll put the papers that have these details in the description too, so...
Sure, that's okay. Anyhow, so what happened was it's in a very analytic form, and I'm saying Hilbert actually replaced the variable in his equations, and in doing so, he gave the variable a range of values that it does not possess.
And this is what you mean about the problem with the laws of pure mathematics.
Yes. So by doing that, he created the interior of the black hole, the alleged event horizon, and its interior down to the physical singularity with those impossible properties.
Yeah, you're saying that this is basically a creation that amounts to an error of definitions? Do you need to get that phone call?
Yes, just a moment.
Okay.
Hello? Yeah, I can't speak. I'm in an interview.
With aliens.
So we were checking out what went wrong with Hilbert's work on the black hole and how he came up with the singularity and started extrapolating non-physical ideas into the interior of the black hole.
Yes. Well, the problem with Hilbert was he was thinking analytically and he wasn't thinking geometrically. So he didn't realize what he was doing with these manipulations of his symbols and violated fundamental geometry, because it's a question of differential geometry in a sense, and without thinking geometrically and just manipulating symbols, he fell into a hole himself, and that's how he created it.
So he sort of stopped thinking about physical objects and was thinking about just mathematical transformations in an abstract sense instead?
Yes, and he made an error there because geometrically, he wasn't thinking geometrically. What the mathematics was actually telling him about a geometry. And so he thought that these analytical manipulations actually produced this geometric form, and it does not, because he wasn't thinking about what his manipulations were doing. And that was a subtle error that Schwarzschild carefully avoided.
And
Why?
so,
Go ahead.
I was going to say, why was this something that caught people's attention so
Yeah, that's
deeply?
what I was going to say. Why is it such a popular mistake?
Well, this is a very interesting thing. I suspect it's got something to do with most people seem to find mystical things rather than scientific things more attractive. And I don't think scientists are actually, in general, immune from this as well. So when their mathematics tells them something, which they think tells them something, they get all excited and let the natural inclination to mysticism take over. And so now we have a situation where physical science is mostly mysticism and superstition masquerading as science because it's draped in complex mathematical symbols that everybody thinks can't possibly be wrong. Well, that's not true.
Reminds me of the church speaking Latin back in the Roman Catholic years on Earth.
Yes, that's quite right.
And
so, and these errors have actually built or facilitated further errors. So we have a whole pile of errors built upon errors in mathematics, and that goes right back to Einstein's field equations themselves, where there's a mathematical problem that he didn't realize.
Before we get into Einstein, though, can you break down a little bit of, I know you mentioned it briefly already, but what are the contradictions with the black hole itself?
Well, first, let's remember that there are various kinds of black holes, types of black holes. Sizes have got nothing to do with it. That's just magnitude. So there are various black holes. There's the Schwarzschild black hole, which is the simplest one alleged. Then there's the Reisner-Nordstrom. That's a charged black hole. Then there's the rotating black hole, which is a Kerr black hole. And then there's the charged and rotating black hole, which is a Kerr-Newman black hole. And
a whole zoo.
Primary types. And all of these black hole universes, and I call them universes because they have a space-time associated with them that is infinite. And all of those space-times are what are called asymptotically flat. The further you get away from the black hole, the space-time they have is a curved space-time. It gets flat, so it becomes regular geometry.
So they have less effect at a distance. They have no effect at some great distance.
Yeah. So in other words, as you move further away, the space-time, they have a four-dimensional space-time continuum gets flatter and flatter. Now, in the case of the Big Bangs, there are three types of Big Bang universes, which is not readily known or generally known to most people. And it depends on the curvature of that is attributed to this Big Bang universe. But the problem is,
and by curvature, you really just mean sort of the degree of effect of these events that are called black holes, these phenomena.
Well, it's a question of the four-dimensional space-time being curved, and as I said, as you move away from the black hole, it becomes flat. And the Big Bang universes, none of these. There's only one Big Bang universe that's flat, and it depends on a thing called the K curvature. I call it a K curvature because it depends on a parameter called, given the symbol K, and if it equals -1, it has a negative curvature throughout the whole space time, and it's infinite in extent. If the curvature K is equal to 0, then it's flat everywhere and extends to infinity. And if the K equals 1, it is positively curved everywhere, and it's a finite universe. Now we see a problem. All black hole universes have a space-time that's infinite, so they cannot be fitted inside a finite universe with a K curvature of 1, which has a finite extent. The other problem is that no black hole universe has a negative curvature of a K equal -1. And the black hole and the Big Bang universes are not asymptotically anything, whereas all the space-times of the black holes are asymptotically flat. So these are things that we can see are inconsistencies between the Big Bang characteristics and the black hole characteristics from a very simple perspective, that they are actually mutually exclusive. Nonetheless, we have astronomers telling us that they're finding black holes all over the universe within some Big Bang universe, when we can see that the black holes can't match a Big Bang universe by their very definitions.
And are these the same astronomers that are promoting the Big Bang universe?
Exactly the same astronomers.
Interesting.
And so is the issue that there isn't much of a sense of the contradiction in the field?
Yes, that's right. They don't see the contradictions. They don't think about these things. What they do is they superimpose these black holes upon one another and superimpose it upon a Big Bang universe. They're never clear about which black hole they mean, the types that I mentioned. They talk all about sizes, but they rarely tell you what kind of a black hole that they mean, and they never really tell you which of the three Big Bang universe they invoke. And the problem is, as I said, they superimpose, but Einstein's theory is what's called a nonlinear theory, which means that if you have a solution for one set of conditions and another a solution for a different set of conditions, you cannot superpose the two and just join them all up and put them all together. So you cannot superpose at all. And yet they're superposing all the black holes upon one another and all the Big Bangs, or rather one of the Big Bangs with the black holes, and having them all over the place within that Big Bang universe. So that's a violation of the fundamental mathematical structure of Einstein's theory. If you want to have a solution for, say, two black holes, you need to write a set of Einstein field equations for two black holes and solve it. No one's ever done that. And the reason is general relativity cannot deal with anything other than one mass. Well, the universe contains a lot more than one mass.
But this seems like it speaks to the difficulty of using mathematics as a tool for modeling the universe, especially because that's a very complex thing, right? The universe is everything that exists, and attempting to take one mathematical equation and model everything that exists according to that equation seems like you're going to run into problems, because models by their very nature are bounded to some area, some time or some place or some event. It's not like you have one model and everything follows, right?
That's quite correct. So, and so playing around with mathematics is a very dangerous game. You're not connected with any physical reality, and you just live in a world of mathematical manipulations. So mathematical manipulations do not amount to science. Science is a physical enterprise by experiments, and using mathematics to usurp laboratory work and physical experiments is not going to lead to anything but disaster. And that's exactly what we've got now in physical science. It's a complete disaster.
Do you have any sense of how that happened?
Well, I suppose it's possibly because the theoreticians seem to think that they're smarter than the average bear, so that everybody has to follow what the theoreticians say, because those who can do sums are brighter than everybody else, which is a misconception that I think we even get in school, that people who can do mathematics seem to have a much more powerful brain than the average person or another person, which is not true.
Well, they have a more powerful analytic brain, maybe, but
quantitative brain.
Yeah, I was actually thinking about this just earlier today. What is the solution to something like this, right? Because you have theoreticians that are doing these big fancy math tricks, and you would expect that at least some of the theoreticians that are in the in-group would be able to look at the equations and be like, well, hey, maybe we made a mistake. But none of them are doing that. And there's reasons why, right? You're inside the in-group, you don't want to walk around and be like, hey, maybe Einstein was wrong. Maybe Einstein made a mistake. That's basically, I think that's blasphemy
Heresy?
in the church. Yeah, that's heresy in the Church of Physics, I think. So you can't really, yeah, exactly. So you can't really knock on Einstein. Okay. So you would need someone from the outside to get involved. But how many people on the outside of theoretical physics actually have the mathematical chops to look at the equations and even understand what's going on?
Well, it does take quite a bit of work to master the mathematical methods. And the problem is, of course, that people want careers, and so they join clubs like any other club and play by the rules of the club. and those who control and run the clubs wield certain powers to admit or expel those related to the club. And I think that this is what's destroyed science, particularly since science now involves such large teams of people spending large sums of public money, and so other interests now prevail, and people don't rock the boat because they might want a career in science, or they've always dreamed about a career in science, or they want to become famous, and they can only become famous by playing by the rules of the club, which allows them to become famous. So I think that this is one of the reasons why modern science has degenerated into what I call mysticism, rather than maintaining a procedure where the proper scientific method is always adhered to.
Have you ever successfully debated, not even debated, I don't like debate because it's like a win-lose. Have you ever successfully had a conversation with someone on the inside of the academy about these sorts of things?
I have had conversation, or I've had encounters with them, not physical conversations as a debate might be otherwise, but Nobel Prize winners and the like, and they are adamant that they are right and that no one else can be right, and they refuse to look at the realities of these mathematical errors. They seem to have a confidence of finality in their own opinions, which is not a scientific outlook, and they resent people coming from the outside looking into their field and pointing out that there's an error there. And of course, since they can control it, they control journals and they control media, and we know that the media is now involved in these sorts of things to promulgate these vested interests, and science is paying the price, and people are now growing up on what we might say television and or media propaganda rather than the realities of scientific endeavour, and are not encouraged to think for themselves anymore. It's groupthink.
Well, there's always going to be people that are thinking with the crowd. There's always going to be people thinking for themselves. The question is, there's some inflection point where enough people are critiquing and analyzing and presenting viable alternatives that, the majority will switch over, right? That's kind of how science goes, where there's some theory and then it's put on the table, and over the years, people critique it and they attack it and they take it apart. And then eventually the ideal is that perspectives can actually shift, right?
That's true, but I feel that we're far from that inflection point at the moment. All the groundwork is there, but it needs to get to that stage where we get to a tipping over into the correct course of scientific investigation.
Well, it's interesting with mathematics in particular, the way that it's been brought into science, because mathematics, I think you would agree, is extraordinary for building things, especially for engineering incredible devices, spaceships, all of this stuff. And so I think that science has kind of taken the back seat to engineering on your planet. It's like science, as we mean science, we mean sort of mechanism, explanation for how things happen. And on your planet, it seems like, well, it doesn't really matter how it happens as long as we know how to predict what will happen and we can build something that way. Do you think this has sort of led to people not really caring whether the explanations make sense or not?
Yeah, like if the explanation for a black hole doesn't have an engineering consequence, then does it matter? This is a Zen koan of science, I guess.
Well, I tend to agree with that. Engineers often work with situations where theory doesn't work. And so they go off and from experience and empirical investigations and generating empirical relations, as in fluid mechanics, for instance. There are many instances in engineering where they have empirical relations that they use to design various apparatus, and so the theories that don't work, they just don't worry about. and so they go with things that they know works, and experience tells them how it goes, and then they can use some mathematics within that confine to calculate the quantities that they are working with. And so they're not concerned so much with these esoteric ideas that scientists have gone off into. And after all, with an engineer, they have to make something that works, otherwise they don't have a job. Whereas with scientists, they can make up all of these stories, write books, but they still have a job.
That's fascinating. Exactly.
Well, their job is to tell stories, right?
Yes. So the engineers have to they work in a different plane, and if the theory doesn't work, well, they discard it and make things work, because that's their job.
But what's really cool about science is it's not just stories, right? They should be logically consistent stories, at least, and even better, they should have consistent mechanism that you can watch from start to finish.
Yes. There are two things in any scientific theory. One, it must be logically consistent, and two, it must accord with physical reality.
Yeah.
That means by what we find in experiments. And if it fails on either ground, then it's not a valid theory. And if it fails on both grounds, of course, it's still not a valid theory. So we have a situation now where we've got illogic involved, being overlooked, and things that don't accord with physical reality being overlooked, and being passed off as being science, because it's not an engineering enterprise where it would immediately fall on its face.
What was the closest that you ever came to having someone who is, let's say, a theoretical physicist actually consider that maybe there was a logical error in one of the equations? What's the closest that anybody's ever come in conversation with you to reconsidering?
Well, I have had people who are well-trained in either engineering or physical science and mathematics that agree with what I've proven, and but they are not part of, you would call, the mainstream of science or academia. So their impact has been similar to mine, virtually nil. I look at it this way: I don't think that anybody involved in these current fantasies are open to conversion. So it has to come from people, as you mentioned before, completely outside the field. So I have had quite a number of people outside the field examining these things from either their own perspective or mine, studying my papers, or a combination of both. And I have seen various proofs offered by other very capable people, and I found that their proofs are sound, and they range from analytical type philosophers to engineers and physicists and mathematical people. But because they are not part of this mainstream movement, they too have found that they've not been able to make any inroads into the community, so that any of the community will admit that there's an error.
Is it possible for these sorts of mathematics to be used for an engineering purpose? Because black holes to me seem like such an esoteric question that it's the perfect place for bad math to hide, because, well, how could you prove that it's bad math? You can't build a black hole.
No, you cannot. And because it is mathematical, the proofs can become quite complicated for those who don't understand the mathematics, and so it's beyond their ability to understand it and why it's wrong, and satisfy themselves on the mathematical grounds. So I try to explain to people that on the physical grounds, as I said before, about the very fundamental nature of black holes and big bangs, how they're inconsistent, and you can't have finite mass with zero volume, and these are things that are easy to understand. But the mathematical arguments require some explanation and training, and most people don't have that. And so it's much more difficult for them to understand and appreciate how these mathematical errors came about. And so I suppose the best way to explain it is to make it as simple as possible, is to get as many people as possible, because the scientific community, no matter what you put before them, those who have alleged to have detected gravitational waves from black holes with the LIGO-Virgo collaboration, and those who have claimed that they've imaged a black hole in M87. But if black holes don't exist, which they don't, how did they manage to get an image of one, and how did they manage to generate curves of gravitational waves generated by black holes colliding and coalescing? Well, the answer to that is very simple. Let's take, for instance, the gravitational wave, since that was alleged to be discovered before the black hole. Now, in the case of this, the discovery paper by the LIGO-Virgo team claimed that they found two black holes merging, and they give a curve in their papers. Oh, well, this is what we see has happened, and they tell us that the parameters of the black holes and how much was lost in radiation of gravitational waves from the masses of the system. Now, when you investigate this, there are two very serious problems with their claims. The first one, pointed out by German physicist Wolfgang Engelhardt, Dr. Wolfgang Engelhardt, formerly of the Max Planck Institute, now retired, is that the LIGO-Virgo collaboration does not have a calibration curve for their apparatus. Now, without a calibration curve, then you can't claim that you've actually measured anything. It's like having a watch, for instance, that doesn't keep time. And you need a calibrator to set your watch to make sure it runs the right time and then adjust it, etc. Now, if your watch is running at the wrong time and it's running fast or slow and you measure a time interval, the time interval is never going to be correct because your watch is not running true. So you need a calibrator. And it's the same with this gravitational wave detector. You need a calibrator. Now, how do you do that? Well, they use mirrors and lasers in their apparatus. So you need to have a known mirror deviation for a known laser input and generate a curve. So that's information that you have from Earth in a kind of laboratory to which you can calibrate your instrument and anything that you have as an alleged observation from space. Well, the calibration curve does not exist. Dr. Engelhardt has challenged the LIGO-Virgo collaboration to produce it, and over years they have never produced it. And the reason why is it doesn't exist. That's the first problem. So you can see that that's a major issue.
And without the calibration curve, you figure that you don't know what the noise is, and so you're just sort of mining noise for signal.
Exactly.
And you can always pull a tone out of a white noise pretty easily if you know what you're looking for.
Absolutely right. You're quite correct. Now, the other problem is with the LIGO-Virgo collaboration is, where did they get this curve from? Since they don't have a calibration curve, where did they get it from? Well, I can tell you how they did it. What they've done is that they've used Einstein's theory and the incorrect equations for black holes and superposed these things incorrectly, since you can't superpose them, but they did that, into some Big Bang universe. They don't tell you which one. And then they generated a great deal of curves from these mathematical, meaningless mathematical relations that they've put together. And so they generated a large database of curves. And then they had a noise in their machine. So then they go and have the computers search the large database of curves that they've generated themselves and find one of best fit, a curve of best fit, in other words. Then they find, okay, the computer gives them the curve of best fit and it has parameters associated with it. Or, well, it's two black holes that have these masses and radiated this amount of gravitational waves. So they take this curve of best fit and say, well, that must be what we observed out in space. Well, they never got out of their computer. They never got out of their apparatus. They can't say that that came from outer space because it's just some noise from their machine, which is uncalibrated, compared to a curve, to find a curve of best fit from things that they generated themselves. Well, that's just talking to yourself.
And
now,
do they pin those curves to celestial bodies or to celestial occurrences?
No, they're not. They're completely generated by mathematical assumptions on a theory that is mathematically flawed.
Huh, so they don't point to a place in the sky where these black hole mergers were happening at.
They do point to a part of the sky, but it doesn't matter where you're pointing in the sky. You can always get a noise out of the machine and say that noise came from that point of the part in the sky that I was pointing to, even though it doesn't matter where you are pointing. You'll get something that will match one of the curves because it's a curve of best fit. Now, so in other words, if you generate as enough curves of best fit, no matter what noise you get, you will always find something that gets a curve of best fit.
There are a lot of galaxies out there, right?
Yes. So here's another interesting point. How many curves of best fit did they generate arbitrarily in their discovery paper? Well, no one knows because they've not published it, but I know. And it was 250,000.
How do you know?
They made 250,000 artificial curves, and then they got some noise from their machine, and they compared it there and found one, and then they said that that's what we discovered. So this is not a discovery of a scientific. This is not a scientific discovery at all. It's misleading. It's misleading the public. It's misleading themselves. And many people who are working on this don't realize that they're misleading themselves.
How do you know that they got these 250,000 curves if nobody knows?
How nobody knows. Yes, well, they know, but they don't tell anybody. And how did I manage to find out?
You're a private detective, is this?
Yes, I have a history. That's my work. I've always worked primarily. I've worked primarily as a private detective in my working life to earn my living. So I used a bit of a technique like that. So I wrote to the Virgo team when they first made this claim, and they were so power drunk with their alleged discovery that they were free and to speak about what they think they've done and how marvelous they were. And I said, well, how did you do this? And that's when they told me about the templates. They call their curves templates, right? And so I didn't know that. They told me, we've got these templates. I said, that's marvelous. And I wrote back to the Virgo team and I said, well, how many templates did you have? And they wrote back to me, so we have 250,000 templates. Well, I've got the email. I've kept it as evidence, of course. And that came from the Virgo team in Germany. So I know from them directly. And I even have the name of the scientist that I wrote to and who replied to me. It's all in the email. So I know for a fact that they had 250,000 curves.
And so this is basically 250,000 mathematical versions of what the gravity waves could have looked like. And so if you apply any one of those curves, or if you analyze your data
without a calibration
and you find any one of those 250,000 patterns in the data, then you can say that, well, hey, look, this must be what we found.
That's exactly right. But remember, it's a curve of best fit. It's not an exact fit. It's a curve of best fit. Well, this is the closest one. That's what we had. Now, since then, they've made quite a number of claims of black hole mergers and black hole neutron star mergers, etc., with lots of others. Now, I can bet my bottom dollar or the proverbial London to a brick that there's now a great deal more than 250,000 artificial curves in their database. And as I said before, the more curves you have, you can fit any noise more closely to any nonsensical curve. And so I wouldn't be surprised if they have a million or more, because as I've facetiously remarked in the past, is that the generation of such numbers of curves is dependent only upon the powers of the computers that you have at your disposal and the stamina of computer programmers.
Now, don't you think, though, that even if on some subliminal level, a lot of these mathematicians kind of realize they might be cooking the books a little bit, don't you think they really believe that they're providing a sense of wonder to the public and sort of giving license to these mystical ideas of eternity and oblivion, and there's a world beyond physics, and it sort of gives people a hope, that maybe there's more than these atoms that they're made out of going
There's
on.
magic.
Magic, yeah.
Yes.
Space magic.
Yes.
It's kind of hard to fault them, because I feel like they probably believe they're doing the right thing by making these fantastical stories up.
That could be true in many instances. However, I've been working away rather on these problems for well over a decade, and many of them know about my work, and instead of commenting on it or admitting the errors, they resort to silence. So what happens when a person who is perhaps in good faith, thinking that they're doing something constructive but not realizing that it's meaningless, get confronted with the truth and then see it very simply presented to them in terms that they can understand, and deciding to turn a blind eye to that? That has happened quite a lot.
I think that it has to do with who presents the message, right? So I think about this a lot in terms of in terms of earth scientists, where there is a tremendous pressure for scientists to stick together, because there's also a tremendous pressure on them from the outside to remain as a unified front to the public. You know, people talk about science as this body of knowledge, and it's used in the public sphere to push policy, to affect politics, to make societies different. There's actually physical things that belief and trust in science does to society. And so anyone who comes around and starts to criticize science is criticizing science as an enterprise.
And sort of threatening the whole fabric of society. I think they're seen that way.
Yeah, exactly. And so it's hard. I think that the idea that people are just staying silent in the face of what you present it speaks pretty loudly in some way, right?
That's probably the best response you could expect.
Yeah, exactly. Because that means
Yes.
that they can't actually take you apart. They can't deny what you're saying, but it's too dangerous of an idea to even play around with, you know?
Well, that is quite correct. And I must add that besides silence in space inside of the facts, I have received a great deal of vitriol poured upon my poor head simply for saying things or pointing out errors. And I've even had death threats. I've had a death threat from a scientist at the Max Planck Institute.
What?
I've had death threats from other places. So you can see that how ridiculous it's become. And complaints about this death threat to the Max Planck Society and the president of the Max Planck Society and to the heads of the Max Planck Institute from which this death threat came resulted in no comment from them.
Well,
None at all. This is quite appalling. And as I said, it's not just the only death threat I've had. I've had a number of them. And then, of course, there are lesser threats and various ad hominems that are forever being levelled at me. I'm not the only one, of course, but that seems to be the kind of response that you will get if you don't get silence.
And what keeps you going in face of all this negativity all the time? Seems like could get really depressing sometimes.
Well, I suppose it can. Yes, it does. What drives me is the fact that first, I don't earn my living as a scientist. And even if I did, I would still take the same course. And I've earned my living as a private detective. And so I look for justice and truth. And I look at the same when I look at science as I was going to court, I've done in the past many times in various cases, and giving evidence or testimony at court and presenting evidence at court so that the truth will prevail. I suppose that's my personal characteristic that keeps me going to work on scientific problems, despite the adversaries that put up such barriers. And I see it as unjust because it's deceiving society at large, which pays for all the apparatus and the wages and the facilities which are bestowed upon these scientists, and they're in large numbers nowadays, and in large groups with large projects. And I think that they should be held accountable before those who are actually paying for them. And if they're deceiving people, then they need to be exposed for that so that people will see for themselves that they are being deceived, and those people should be held accountable for what I see as some form of misconduct. The other thing is that I'm very concerned that people have been lulled into believing that scientists have all the answers for them and only science will be able to bring us forward. Well, I think that's a great misconception, and I think it's a great danger that the decisions for our socio-economic structure and interrelations should be left so much to the words or the claims of scientists. I don't believe that scientists should decide where our society and what direction it should go and how it should work. There are many other things that are involved. There's law, there's justice, there's economic questions, there's right and wrong. These sorts of things need to also be involved. And I don't believe that scientists should be given free rein to decide for us, the society at large, what is and what is not.
Yeah.
That's hard to disagree with. I guess I see it as an extension of the legal sort of analogy that you had at the beginning, right? Which is that your background in private investigation gives you the sense of a legal proceedings, right? You collect evidence, you put it down in front of people. But to extend that metaphor, I mean, people are wrongfully convicted and spend decades of their life in prison. And in the case of science, it seems like a theory that is wrongfully convicted can suffer the same fate until enough people come around and revive it and take up its cause again.
Do you think that things will change now that there's more interest outside of the academy than ever before, or at least in several hundred years? It seems like there's these perhaps small right now, but small alternative communities that are taking on these matters outside of the academy. Do you see any hope there?
Yes, I do see some hope there. It gives me encouragement because it shows me that there are people outside the field, if you like, that are critically examining what is being told to other scientists or the public at large or students at high school. And so this is a movement that I encourage because freedom of thought and freedom of speech, these are fundamental to not only the development of science, but for the human condition. And if we do not have that, then I don't see how we can achieve anything great, anything good, if we're denied this fundamental natural right. And so I do see encouragement in small groups, because small groups gathering together from different perspectives produce many good ideas so that many more people come to question these things rather than passively accept what they're being told, as people might do when they're sitting in front of a television set and see a television commercial and passively receive information and process that and without thought. So we don't want that happening with more important things for that, such as science and people's livelihoods.
And
so I do see it encouraging.
Yeah, nice. So it's almost like this idea of being able to freely pursue ideas is necessary for self-correction in science. And if there's no ability to blow the whistle from within, then perhaps change has to come from outside.
Well, I look at it from the perspective that this idea of, so we're pinpointing this notion of the black holes to what, 1915? Ish?
Well, 1916 to be more accurate.
All right. So Hilbert's equations were published in 1916, which was a misinterpretation of the Schwarz.
Some sort of mistake was made at that point.
Right, exactly. So that has been the foundation of this discipline in those intervening years. But it feels like the reason for that is because people really don't like to reinvent the wheel, right? Have you noticed this? Where you have to start with a collection of assumptions that you take for granted. Because if you don't, then you basically can't make any forward motion because you're always going back over the same territory. And this might be just sort of an out of control version of that tendency, right? These are such deep-seated assumptions.
That's true. Yes, that is true. Making assumptions that don't have any solid basis in science, bearing in mind that we have to be guided in science by what we see in the laboratory. Science is always physically based. And Isaac Newton himself, a great mathematician, always emphasized that any, what he called natural philosophy, cannot proceed on simple assumptions and by themselves. They must be rooted in experimental findings. And Newton carried out many experiments and examined the experiments of others very carefully before he developed any mathematical relations.
Yeah.
And he did it primarily with geometry, but he did a lot, of course, as you know, with mathematics. So he was a very careful scientist in this regard, and he approached it correctly. So forgetting that science is rooted in experiment and observation, and then instead replacing that with mere assumptions, you can assume pretty well anything you like. And if you have logical consistency with your assumptions, it doesn't mean that you're presenting something that's of scientific value, because a logically consistent system based upon false assumptions is still a fallacy. It's a fantasy land.
Yeah. Well, okay, so the LIGO detector can be attributed to noise, right? Gravity wave detection comes from lack of calibration. It's noise.
They've got nothing but noise.
What's that photo of the black hole? What is that?
And sort of an even bigger question a lot of our listeners were wanting to hear your thoughts on was, what exactly is this thing that everybody's pointing at in general that's called the black hole? Like, what is this? What's going on with this occurrence?
Yeah, and is that the same thing that got photographed?
Yes, well, I'll answer both of those, and I'll start with the photograph. It's a very similar situation to the LIGO, except that they have some kind of calibration because they have various radio telescopes all around the world, and they can calibrate all of those, and they combine them to make a giant, if you like, radio telescope. And so they can peer further into the depths of the heavens than they could otherwise. However, the problem they have is a similar thing. What they did is that they generated what they call synthetic images, and they placed these synthetic images into what they call is their synthetic image library, a synthetic image library. Well, synthetic image library is a pseudoscientific way of saying a database of fake images, synthetic images. You made them up yourself, so they're fake images. And so the problem is that how many of these images did they make? Well, they used 420 different models. And from those 420 different theoretical models, they generated more than 62,000 fake images, and they call them synthetic images, and they put them in their synthetic or fake image library. Then they get some noise from their giant radio telescope and run this noise through their more than 62,000 fake images to get an image of best fit. Now, what they did was they did not, when they extracted the closest image, they didn't use that particular image, but what they did was they said, well, this particular image in our synthetic database has these parameters, and it's closest to the thing that we've just generated with our radio telescope, the image that we just made with our computers. So that means the thing that we've got an image of now that we've generated with our computers, it actually has the parameters of this synthetic image, because that's the closest one to the image that we've just made. So instead of taking the image out, they used the parameters and applied it to the image that they created.
And the parameters are the physical parameters of the object, or what do you mean by parameters here?
Yes. Well, the parameters are its mass, its orientation with respect to the Earth, and all the others that they've reported on, they all come from their synthetic image database. So it's not an image out of the database, as I said, which is different to the LIGO team. They took the LIGO team took a curve of best fit and used that curve of best fit as the presentation of what they've got. Whereas in this case, rather than using their image of best fit, they just took the parameters of the image of best fit and assigned it to the image that their computers generated. So once again, we see that they've actually not got out of their apparatus. The other curious thing about it is they've managed to give a resolution to their image, which is way beyond the resolution of the instrument. Well, that's quite miraculous.
No.
So you see that there are so many problems with this.
And let's talk about some of the other lines of evidence that people point to, like planets orbiting nothing or something like this. Do you have any alternative explanations for these bizarre events?
My work in science has never been one of discovery. My work has also been nothing of new theories. Mine's been an analysis of theories that have been proposed to see if they're consistent and logical, and I find that they are not. So to come to the question of, do I have a theory of anything? No, but I can tell you something about the question that you've asked me in this. And it goes again back to Isaac Newton, who pointed out that if you have a system of, say, 2 stars, a binary system, or more, if you have more, the objects are not rotating one around the other. They are rotating around their common centre of mass, which is called a barycenter. So if you take, say, 2 identical stars, for argument's sake, separated by some distance, and they are rotating against the background stars from Earth, from when we look at them, we see them, well, they're both rotating, and they seem to be rotating around some central point. Well, that central point that you're looking at is really just the centre of mass of that system. And is there a mass located at the centre, at that barycenter? The answer is no. The 2 masses are rotating around a point in space that contains nothing. And Newton was very careful to point this out in his famous book called the Principia. Most scientists have never read Isaac Newton's Principia. You can ask them, and you will find almost invariably that none of them have even thumbed through the Principia. So they don't even understand Newton's Principia. They don't understand what Newton actually did. They only have what they've been taught in modern textbooks, and so they are not conversant truly with Newtonian mechanics. And you find this in Newton's Principia, and Newton is correct. They rotate around a barycenter. So, as I said, at the barycenter, there is no mass. But if you're looking from afar, you would think, oh, well, they're rotating around something. Yes, but they're rotating around their barycenter. So there's nothing there.
Well,
so to come to the assumption that there is something there is a mistake.
It's really fascinating because Newton does these incredible descriptions in his work of what's happening in the heavens. You know, he kind of nailed this inverse square law with Hooke, but at the end of the day, he says, I have no idea what's causing this.
Hypothesis non-fingo?
Yeah. So it's almost like
That's correct.
Mathematicians today, they don't really have that same humility. They're like, it's a mystical, magical object, of course. And that's really fascinating because Newton was like actually into magic and stuff, but he didn't let it contaminate his science.
That's quite true. He had a mystical element to him with the amount of time that he spent studying alchemy, but he didn't let that interfere with the fact of his basic approach to natural philosophy. It must be rooted in experiment. If you don't abide by experiment carefully, then you're not doing natural philosophy. You find a very nice explanation of what Newton did in one of his editions there, written by his editor, Roger Coates. Coates explains Newton's approach, Newton's mentality, the way he did things very, very nicely. And I recommend it to anybody who's interested in these subjects to get a copy of the Principia and read Coates' introduction to get a handle on how Newton approached scientific problems. And then if they're further interested, I recommend them to carefully study the Principia. It's not easy going. However, you get a better feel for science, what science is about, by studying that book than I think you will get from studying any modern textbook on physics and astronomy.
Yeah, it's a good one. One thing that comes to mind for me is that there was a huge influence of the church in that day. And so people sort of had someone to look for when it came to questions of metaphysics and esoterics. And today, religion's never been less popular on Earth. So I wonder if these academicians haven't really absorbed some of the responsibility that was formerly taken on by the church.
That is a very good point, and I tend to agree with you. And it doesn't matter to me what persuasion of your spiritual outlook might be. I think that it has been divorced by science, divorced from science with hostility. And science does not want to have any kind of spiritual influence or any kind of philosophical influence or to guide them into how they will do things. And to me, this is a loss of some aspect of our human nature and is an artificial way of approaching science, because ultimately we want what is right, what is true, and these come from deeper things than just science. And Newton was a man of spiritual character, and those kinds of ideals sat within his personality as well. And if you don't have those, then you have no moral compass. And if you don't have any moral compass, you can become like a criminal. Criminals don't have any moral compass at all. We can't get rid of them. We can only try to set up systems that contain them. But if we divorce all our endeavours from these fundamental guidances, guiding lines, I think that we lose quite a lot. And as I said, it doesn't matter what your spiritual outlook will be, because there are various spiritual outlooks. But these are the fundamental guideposts there. Casting them aside, I think, throws away a great deal of what we need to keep to be able to keep ourselves on track to do proper science.
It sounds like your strongest suggestion to people that are starting down this path is to go back to the original sources.
Absolutely. Go back to the original sources. Don't believe what you're being told by your teachers. Not because they're being malicious. Most of them are not. But they don't realise that what they're telling their students is something that has been corrupted over a long period of time, and they don't understand it themselves. So they've accepted these without thinking carefully as well. So they're not passing it on to their students with malice at all. But they should have done the same thing. So the question is, or the issue is rather, yes, encourage people to think for themselves, to go to the original sources and analyse them so that they can understand the course of the discipline in which they are devoting their careers or their energies. Because otherwise you will find that you are just accepting things that are dogmatic. And dogmatism is the death of science.
Not even dogmatic necessarily, but just so detail-oriented that you lose sight of the larger picture, right? Because all of this comes back to study of the physical world. And if you go into theoretical mathematics or theoretical physics thinking that you will study the physical world and you don't understand that there was a departure 100 years ago where it stopped studying the physical world, you'll never actually be able to make any kind of change. And so it's worth going back and looking at all of these old texts because they've stood the test of time. They've been interpreted and they've been used for other functions, but they're still the ones that people talk about. People still talk about Newton. They still talk about Einstein. They still talk about Schwarzschild and Hilbert. Like, these are people that...
Schwarzschild.
Sorry, I don't know Schwarzschild, actually. But these are people whose work, if you're going to be doing physics or if you're going to be doing science, you should know. And I think that it's forgotten because who has the time? Who has the time to go look at all those old papers and understand the old mathematics? It's easier to read something that's flashy and new and fast and modern.
Gotta get grants.
Yeah.
That's quite right. So but I do encourage to go back to the old papers. If you want to know about the human race, and you have to study the history of the human race. So you have to go back and read about the old societies and how things were done and learn those things. So you don't discard what has happened long in the past. It's the same with science. If you discard the original papers, then any errors that have been promulgated through time and are now in contemporary textbooks, you never realise that there are errors. And this goes back even further. We can go back, for instance, as another instance, to 1859, where Kirchhoff, there's Kirchhoff's law of for electric circuits. I'm not talking about those. I'm talking about Kirchhoff's law of thermal emission. And this goes back to 1859 when he published a paper. Now, before him was Balfour Stewart, a Scottish scientist who was working on thermal emission as well. And he published a paper in 1858. And Balfour Stewart was a much more careful experimental scientist. And he, in his paper, he talked about the emission of radiation from heated plates, etc. And Kirchhoff developed a thing called Kirchhoff's law of thermal emission in 1859, where he says if you take any opaque cavity that's large enough so that diffraction effects are irrelevant, and you bring it to thermal equilibrium, then the radiation within that cavity is the same at any temperature for any cavity, no matter what it's made of. It's independent of the nature of the cavity and its wall and its the nature and form of that cavity. Now, scientists have believed this strange thing that, for instance, if you have a box made of carbon and you have a box made of silver and you have them at the same temperature, then you will have the same radiation field within inside the boxes. Well, this is quite a magical thing. How can the nature and form of the cavity have no effect on the radiation field? It's quite mystical. And yet that has become implanted very deeply in physics, and it affects a great deal of physics and even engineering. However, Dr. Pierre-Marie Robitaille has conclusively proven that Kirchhoff's law of thermal emission is incorrect. It is not true. Arbitrary cavities at the same temperature do not contain the same radiation, and this radiation has been called black body radiation for the simple reason that if you made it out of carbon or you made it out of silver or you made it out of stone, at the same temperature they have the same radiation field as a carbon cavity. So they're called black body, because in Kirchhoff's day, to line their cavities and make them black, they used lamp black or soot. So But if you look at today, we have a thing called resonant cavities, which are used by communications engineers, for instance, everywhere. Resonant cavities tell you that Kirchhoff's law can't possibly be true, because otherwise you would not be able to build a resonant cavity.
Like a laser.
Pardon?
Like a laser? Well, like a resonant cavity, yeah.
Like a laser, yes. So you can have a resonant cavity.
Where you get sort of a standing wave of light building up, right? It's something like you get all these light waves kind of piling up on each other and resonating.
Correct. Absolutely right. So now if Kirchhoff's law was true, you wouldn't be able to do that because the walls would absorb all the radiation and thermalize it.
Gotcha.
And so the radiation field would always be thermalized to the black body at that temperature, which is contrary to what physical reality is telling us. Lasers, other resonant cavities in communication, they all exist. We have resonant cavities are used in MRI. MRI scanners contain resonant cavities, you see. So
what is
the bottom line is...
Yeah, what does this tell us about the black hole? I assume this tells us about the black holes, something interesting about the black holes.
Yes, it does. Exactly right. It tells us more than that too. It tells us about the sun and the stars. But I'll bring it to black holes because it's right on point here. Is, for instance, there is an equation on Stephen Hawking's gravestone, and he is now buried next to Isaac Newton in Westminster Abbey. And in this equation, he gives the equation for the temperature of a black hole. Now, the problem is this is related to Hawking radiation. And Hawking radiation is said to be radiation coming from a black hole, and it's a black body radiation at a certain temperature. However, as Dr. Robitaille has also shown, that to generate a black body curve or a black body spectrum, or even a Planckian spectrum, since they follow a Planckian frequency distribution, what is required is a physical vibrational lattice. If you do not have a physical vibrational lattice, such a spectrum cannot be produced. That's why gases, for instance, cannot produce a Planckian spectrum. It's impossible. So gases cannot do that. Only condensed matter can do that. Now, in the case of a black hole, it does not have a vibrational lattice. So it's robbed immediately of any physical capacity to be able to produce a black body spectrum.
And that's because it has no volume?
That's because it has no volume. You have a mass, a finite mass, that's in zero volume. So what's the phase of that mass? Solid, liquid, gas, what is it? And it has no volume. So it has no vibrational lattice. It's impossible to get a black body spectrum from anything other than condensed matter, and that requires a vibrational lattice. The black hole does not have a vibrational lattice. So we see from physical grounds, Hawking radiation does not exist. It has no capacity. The black hole has no capacity to generate a black body spectrum. Now we go further, back to the equation. I've used a very simple example in explanations to people, and I'll use it here. If you have a bake a cake in an oven, and you know when you take the cake out of the oven, it's a uniform cake because you've made it the same way with the recipe. And the temperature is such that it's pretty well, it's uniform throughout the cake. Now you take the cake out of the oven. We cut the cake in half. Everybody knows what? Well, if you cut the cake in half, are the temperatures of those two pieces of cake different now, or are they the same? If we take those two pieces of cake and put them back together very quickly and join them up, is the temperature of the full cake now the same? The answer, of course, is yes. Everybody knows that from their work in the kitchen. Now, this is a very fundamental characteristic of matter. And if we take a cake or a brick, if you like, and we cut it in halves, those things that are cut in halves are called extensive properties of the matter. And for instance, mass. If you cut the cake in half or the brick in half, you have two pieces that are equal in mass. That they are half the mass of the original. You put them back together, they add together, so they're additive and they make the full mass. The same with volume. You cut the cake or the brick, you have two pieces of half volume. You put it back together, you get the full volume. So volume is additive, mass is additive. This is another way of saying that these are extensive properties of matter. But the temperature doesn't change. Neither does the density of the cake or the brick. Neither does the pressure. These are called intensive properties of matter. Now, an intensive property is temperature. The temperature is an intensive property. Now, so this is enshrined subtly somewhat in the zeroth law of thermodynamics. So if you have a theory in which the temperature of an object depends on its mass, then you have a theory that violates the zeroth law of thermodynamics in a fundamental characteristic of matter. So let's look at Hawking's equation for the black hole temperature. He has the temperature inversely proportional to the mass. So in other words, if you double the mass, the temperature is strangely halved. Or if you were to halve the mass, then the temperature strangely would be doubled. Well, we just halved the cake from the oven and we halved the brick from a kiln, as the temperature doesn't change. If we cut the brick in half or the cake in half and the temperature of each of those pieces doubled, it would be very, very strange because it doesn't happen. And that's because it doesn't happen. It's not true. So any theory that has temperature non-intensive is a false theory. So Mr. Hawking's equation, etched into his gravestone in Westminster Abbey, is a violation of the zeroth law of thermodynamics, and it's nonsensical. So it's meaningless. It's wrong.
That seems like quite a disaster.
It's a disaster, yes. Now, I've communicated this myself to the Cambridge Dons, and I've communicated to the Stephen Hawking Foundation and the Westminster Abbey people, and they've all not responded. It's just silence. Because it's such a great embarrassment now that it's been pointed out to them that they've got a serious violation of one of the most fundamental laws of physics.
Is this related to the idea that a body can't do work on itself?
Yes, that's true. It is related to that. For instance, as Dr. Pierre-Marie Robitaille again has explained, if you take a gas, a free gas, it's not in a container and it's out in space. According to the astronomers, these gas clouds get so large that they can collapse on themselves and produce a star, a gaseous star. Well, now you have an object doing work on itself to raise its own temperature and decrease its own entropy. Well, that's quite impossible. That's a violation of the first and second laws of thermodynamics, and the temperature relation is a violation of the zeroth law of thermodynamics. So the idea of that this happens is quite wrong. And yet astronomers believe that these gas clouds collapse. Now let's think about this gas cloud. They use the kinetic theory of an ideal gas to describe it, but the kinetic theory of an ideal gas relates to a gas that's contained. It's in a container. If you don't have container, you cannot describe volume. And what's the equation for the relation for an ideal gas? Pressure times volume is equal to, well, that's PV equals nRT, where temperature is T, R is the gas constant, N is the number of moles of the material, V is the volume, and P is the pressure. Now, this is defined in terms of a container. So if you don't have a container, you can't define volume. You can't define volume, you can't define pressure or temperature according to this equation. Yet the astronomers use this equation for a large gas, uncontained, a free gas out in space that collapses on itself due to gravity. Well, the problem again here, another problem here is that in the kinetic theory of gases of an ideal gas, using this equation, there are no forces between the particles of the gas, except when they collide with one another in the walls of their container. So now to infuse the ideal gas particles with gravity between themselves is a violation of the kinetic theory as well. So the astronomers have violated the kinetic theory of ideal gases and the laws of thermodynamics to enable them to have clouds of gas in space that are not contained, collapse upon themselves and form stars.
So I wonder about that because as far as I understand it, space has a lot of electromagnetic properties along with gravitational properties.
Space or the stuff in space?
The stuff in space, sorry.
Gotcha.
In space, there's a lot of electromagnetic paradigms as well as gravitational paradigms. And so the star formation theory, which goes that gas in a vacuum collapses in on itself, couldn't it be first bound electromagnetically in such a way that it increases collisions between the molecules that then stick together, that then cause more and more molecules to stick together to each other, and eventually gravitation takes over? Like, isn't there some way to have both be true?
Well, now we're venturing into some speculative things on the nature of how stars are formed. And that's not something that I want to go into at this stage because I don't have answers to that.
Right.
Dr. Pierre-Marie Robitaille has suggested that it's actually condensation reactions that form the stars. And so it doesn't involve electromagnetic confinement of any kind. But this goes beyond what I want to discuss because the astronomers don't use these ideas. They are just talking about gases, kinetic theory of ideal gas, and gravity. And when they combine them to form the stars. So what we see is that their theory cannot be right because it's a violation of the kinetic theory, it's a violation of the kinetic theory of the laws of thermodynamics, and it has objects do work on themselves, which is again violations of the laws of thermodynamics. And it also has a very strange result, is that a gas cloud, which has all gases have a positive heat capacity. You put heat into it, the temperature goes up. If you put heat into it, the temperature does not go down. However, according to the theory of gaseous stars, the gas cloud gets so large somehow or another and it collapses, and then the heat capacity of the gas goes from positive to negative, so that you put heat in, the temperature goes down. You take heat out, the temperature goes up. Well, This strange result is because they have violated the kinetic theory of ideal gases and the laws of thermodynamics, and they don't realise this. And then they think that they've got this strange thing that has gases in the form of stars having negative heat capacities. So we ask a question of the astronomers. Please tell us how large a cloud of uncontained gas in space must get, or how massive it must get, before its heat capacity suddenly changes from positive to negative. Well, they can't answer that because it doesn't happen. It's an impossibility. But their theory require it.
These seem like very difficult things to walk back on. I wonder how you imagine that such a recourse could even take place.
Yeah, like what does a conversation look like where somebody who has devoted their entire life to the study of this.
Dynasties,
yeah, right? Like 100 years of research into it that someone's like, man, you might be right.
Yes, I can give you a specific example. I have had email correspondence with Professor Eugene Parker. He's an emeritus professor now. He's in his 90s. And you might recall that the Parker probe sent to the sun by NASA is named for him. The first time that they've named a satellite after a living scientist. Usually they name them after those who are deceased. So he has that honour. And I had email communication with Professor Parker regarding his theory of the solar wind. Now, Dr. Pierre-Marie Robitaille and I have written a paper on Professor Parker's theory of the solar wind and showing that this theory cannot be correct. And I pointed this out to Professor Parker himself. I said, well, take your equation for the temperature of the solar wind. You can write it in this way by substituting your for your parameters or your shorthand parameters. He makes shorthands. He sets a symbol to a whole bunch of symbols so he can make it more mathematically tight and to be able to manipulate. And here's another example of manipulating mathematical symbols without knowing what's going on and producing something that's incorrect. Because his temperature for the solar wind contains two parts. One part is intensive, which is correct. Temperature is intensive, and it comes from the kinetic theory of ideal gases. The other part is non-intensive, and it comes from using gravity. Now, in the single equation, he has one part which is intensive for temperature and one part which is not intensive for temperature. So his equation for the temperature of the solar wind is invalid. You cannot combine one part that's intensive with one part which is not intensive to get an intensive quantity for temperature. So his equation in his theory, therefore, of the solar wind is incorrect. Now, when I explained this to Professor Parker and referred him to our paper, he refused to accept it, told me that the argument would then be a violation of the conservation or of momentum. It's completely irrelevant. He didn't seem to realise it's got nothing to do with momentum. It's all got to do with temperature and how he got a temperature equation using the ideal gas and ideal gas equation combining with gravity. So this is telling us you cannot combine the kinetic theory of an ideal gas with the theory of gravity and get anything that's scientifically meaningful because it produces non-intensive temperatures. And what Professor Parker did was manipulate mathematical symbols from combining different theories, producing something that's a violation of the laws of thermodynamics without him knowing it. And when it's pointed out to him, he refused to continue the discussion.
What would an ideal response look like to you? What could you even imagine someone in that position saying?
Well, if Professor Parker, for instance, in this instance, looked at it objectively, he would have to say, yes, you're right, my equation is wrong, therefore my theory of the solar wind is wrong. Unfortunately, that's the case, and he would have to accept that. Same with Mr. Hawking and all those who profess black holes. They would have to say, yes, this equation that we've got on Mr. Hawking's gravestone is wrong, it's completely wrong, it can never be right, and it's a great problem. We should fix this, but they don't.
It's literally set in stone, though.
I think you'd have to offer a cooler equation. I think the only chance of dealing with it might be putting a better equation on his tombstone instead.
Maybe. I just think, like vandalism, you mean? Like you show up in the middle of the night and you like change the equation?
Steve Crothers was here.
We can go Yeah, we can go a little further now with this black hole business with Mr. Hawking, and because Jacob Bekenstein and Hawking produced an equation for black hole entropy. Now, we know that entropy is extensive. It's an additive property. The entropy of a system is the sum of the entropy of its parts, just like the mass of a system is the sum of the masses of its parts, just like the volume of a system is the sum of the volume of its parts. So entropy is an extensive property. Now, the black hole we've seen has a temperature problem. It also has an entropy problem, because the Bekenstein-Hawking black hole entropy equation is given in terms of an area, the surface area of the event horizon. Now, the surface area of the event horizon can be given in terms of 4 pi r squared, where r is the so-called Schwarzschild radius, and that contains the mass of the black hole. So if we put that into the equation for the black hole entropy, we have an equation for entropy that says that the entropy is proportional to the square of the mass of the black hole. However, mass is extensive, but mass squared is not extensive. For instance, if you take a mass m and it's made up of lots of little masses, because mass is extensive, it can be m1 plus m2 plus m3, etc., to some finite number n. And if you take this and square all of that, m1 plus m2 plus m3, etc., all squared is not equal to m1 squared plus m2 squared plus m3 squared, which tells you that m squared, the mass squared, is not an extensive property. Mass squared is not. So the Hawking-Bekenstein equation for black hole entropy has the entropy, which is extensive, equated or proportional to the mass squared, which is not extensive. So this is a contradiction. Then, so we see that the black hole entropy equation is also false for a violation of the laws of thermodynamics, because it does not have the right thermodynamic character on each side of the equation, even though it has the correct units on the same side of the equation. So in any thermodynamic equation, we need two things. They must have the same units on each side of the equation, which is common in any kind of analysis, and it must have the thermodynamic character. If it has the same units but not the thermodynamic character, then it's not valid. So the black hole entropy is also false. This equation is scribbled onto or chiseled into a plaque outside one of Mr. Hawking's former offices somewhere in Cambridge or I'm not sure exactly where, but it's there. So this equation is false. Now it gets worse. According to the astronomers and the astrophysicists and the cosmologists, the total entropy of the universe is equal to the sum, the additive, right? The sum of the black hole entropy and the entropy of the universe outside the black hole. Well, they've given you a statement here that the total entropy of the universe is therefore extensive because it's the sum of two entropies. But one of those terms is the black hole entropy, which is not additive. So that statement is another contradiction. So their statement for entropy of the universe is completely meaningless. Well, it's false.
So it sounds like these sorts of contradictions abound, which would make sense because if there's a lot of people who are putting together equations, they are people that can't necessarily be questioned by someone who comes up behind them, right? Like Stephen Hawking is such a totemic figure that who can question him? Who can question Einstein? Who can question Hawking? Who can question the big figures? This is always the case. Who can question Elon Musk? You know what I mean? These are all figures that can't be questioned. And so to me, it seems like the only solution is to build really robust communities that run in parallel to academic physics. And the best strategy would be to demand time for private projects on these big instruments, you know? Like there should be time for hobby physicists on CERN. There should be time for hobby physicists on the telescopes. There should be time for people who aren't part of the academy to be able to use the tools that public money has bought. And
of course,
maybe it could with enough time, create a parallel narrative.
Of course. Yes, we need to have replication by independent people, but this is not allowed anymore. replication by independent teams or independent scientists, this is not allowed. And the cost of the equipment is so large that nobody can do it without the money from the public, and you don't get dual projects. So it's impossible to replicate what they have claimed. And if you don't have replication by independent parties, you don't have a scientific discovery, you have an allegation and nothing more. So this is a very serious issue, and I agree with you.
So it seems like this is the lever that people can pull on, right? Make sure that there is access to the tools that are necessary for independent verification. It has to be.
Quite right.
And from what I understand, it has happened in the past. I believe maybe it was in the 80s, there was a fair amount of public time on some of these big telescopes available. But it seems like it has happened and it could happen again.
Well, I saw something really fascinating. So there's, Stephen, do you know the Journal of Cosmology?
Yes, I've heard of it. I've not contributed to it and I haven't read it, but I know about it.
Well, so I remember seeing a few articles a couple of years back about an analysis of photographs from the surface of Mars, where the author suggested that perhaps there was life on the surface of Mars in the form of lichens and funguses. And it was interesting. It was an interesting comparison. All these photographs of the Mars rover where the author points out, like, look, it appears that something's growing on it. Look at this picture of the ground. It looks like mushrooms have blossomed. Very cool. But it's on this website, Journal of Cosmology. It's not, as far as I can tell, not a peer-reviewed journal. But then, this person who runs the journal, I imagine the editor, managed to get his research published in either PNAS or PLOS One, one of the journals that's peer-reviewed, along with a bunch of scientists that were academy scientists. They had positions at universities, and they were listed as authors on this paper.
So he did a lot of coalition building, basically.
Yeah, he built a coalition of people inside the academy and got his ideas published in a main journal about there being life on Mars.
Potentially.
And so this seems like a strategy as well. Go ahead.
Yes, that's possible, I suppose. It's not something that I've explored myself, but there are a few points to make. Is that first, all the major journals, Physical Review, Astrophysical Journal, etc., monthly notices of the Royal Astronomical Society, all these prestigious journals, these journals are responsible for the ruination of science. They are the people who have ruined science. So this is a very big problem. The other thing is that I remind people of a quip made by Leonardo da Vinci. He said that anybody who resorts to an argument by authority is not using their intelligence, only their memory. So that's the problem. Authority is taking control of everything, and the authority is with journals, prestigious journals, that are ruining science. I can give you a very, very interesting example of this as well here in Australia. Now, you might have heard of the Parkes Radio Telescope. It's a very large radio telescope. And for 17 years, the experts, the scientists at the Parkes Radio Telescope, were publishing peer-reviewed scholarly papers in the Astrophysical Journal and the monthly notices of the Royal Astronomical Society and such, of the discovery of short, intense radio bursts coming from space. And they called them peritons. They gave them a name. And as I said, for 17 years, they published all of these papers, all peer-reviewed in these prestigious journals. Finally, after 17 years, they realized that there's a problem, a mistake. The radio signals were coming from
inside the house,
but from the microwave ovens in their lunchroom and in the lunchroom of the visitor center nearby.
Oh, no.
I am not kidding you.
That's amazing.
These great scientists think they're great scientists, published by these world-renowned journals, and none of these scientists could even have the capacity or the competence to be able to tell the difference between something coming from space and something coming from the microwave ovens in their vicinity and it took them 17 years to wake up.
Well, the fact that they did wake up and the fact that we're sitting here and talking about this seems like it points to a positive future, because the alternative is that we would have never known.
Well, my perspective as a careful scientist is that you should be very careful about what you publish, especially over a long period of time like 17 years, when you should have known. You should have known as a radio astronomer sources of radio contamination around your instrument, bearing in mind that this is a parabolic mirror, a parabolic dish, right? And you get diffraction from the surroundings of any radio signals can be diffracted over the edge of such a dish and into your detector. And that they took 17 years to discover this instead of 17 weeks or 17 days discourages me as to their competence.
But they published an apology eventually?
No, they didn't publish an apology. It was published, but it was brushed aside as something that, a bit of a laugh. No, that's not how science is done. And these are the very people who are telling us about black holes and big bangs and all the other phantasmagoria that they're passing off as science when it's nothing but mysticism. The very same about the peritons, the very same about temperatures of black holes scribbled onto their gravestones, the very same who have clouds of gases collapsing on themselves and changing their heat capacities. All of these people, and over a period of 100 years, published, or more than 100 years, if we go back to Einstein, of course, to 1905, publishing in the prestigious journals all of this nonsense that has turned science into what I consider to be largely a carnival sideshow.
Well, in some sense, it seems like the healthiest thing to do is to have a laugh about it, I guess. I mean, I'm not sure how you can move past something that's been such a production without either laughing or crying. And
yes, but none of them seem to be embarrassed by their errors. None of them seem to want to admit, well, we've made this error, perhaps we can make some other errors. Yes, you have made other errors. Now, the most sensitive radio telescope that's ever been built is 54 to 2.6 in Armenia. The project was designed in the supervision of the construction by Professor Paris Harouni, and it was built by the Soviet Union. And this radio telescope has a self-noise of 2.6 Kelvin. The closest other radio telescope in the world is an order of magnitude higher. This is the most sensitive radio telescope ever built. It's actually a dual telescope, optical and radio. And Professor Harouni pointed it at the sky, and he took a sample for the alleged cosmic microwave background, and he got back from his device 2.6 Kelvin, which is only the noise of the machine of the device, which means that he got 0 for the cosmic microwave background, which tells us that the cosmic microwave background does not exist. Yet, Professor Harouni's discovery was suppressed. For 10 years, he waited for radio laboratories around the world to confirm or deny the result of this direct measurement of the cosmic microwave background that's alleged to exist, left over from the Big Bang. Not one replied. When I learned about this telescope a few years ago, I went searching for Professor Harouni's papers, which were eventually published in a small journal on electromagnetism located in Greece. I found that this paper had been removed from the archive of the records of that journal. So I then went to Armenia. Well, I didn't go physically, but I approached scientists in Armenia and located a copy of the journal on their bookshelves in their laboratory and had them send me copies of it.
Wow.
I then wrote to the editors of the journal with copies of the journal, showing the article by Professor Harouni. And I said to them, why is this not anymore in your journals, in your physical or electronic archive? Where is this article? Since I have a copy of your journal, which is located in Armenia, here it is. Well, the current editor, or the editor at that time, knew nothing of the article, couldn't find it. And so we approached the former editor, who knew Professor Harouni. And the former editor told me in an email that, it's been a clerical oversight. Well, how does a clerical oversight remove a paper from your physical and your electronic archives? How does that happen? So for 10 years, no radio laboratory would communicate with Professor Harouni because it completely proves conclusively that the CMB does not exist.
Has anyone ever repeated? Has anyone ever repeated his measurement?
Yes.
I mean, the CMB
I think the telescope was taken apart.
No, Professor Harouni died, and after the collapse of the Soviet Union, Armenia had no money to maintain this keep this telescope operational. However, the telescope is in working order. It just needs money to have it back online, to refurbish it. Now, that would cost quite a bit.
How much
Efforts
money?
are being undertaken to do that. However, there is great resistance from the scientific community to allow Professor Harouni's telescope to be reinstated because of the fact that it proves that the CMB does not exist.
Well, this is a great opportunity for the alternative motion or the alternative movement of science to basically buy a telescope, right?
Crowdsource
it.
Yes.
How much money do you need?
Crowdsource it, perhaps. Well, I would say, given the age of the telescope and the systems that it will need, it will probably cost something of the order of $30 million to get it up into at least. So it's a lot of money. And as I said, it was built by the Soviet Union. So that source of public funding will not come from Armenian government because it's a small country with a small economy and they don't have, and then there's pressure from the scientific community upon them not to even spend any money on it. They want it to go away. But the niece of Professor Harouni, Professor Ararat Sargsyan, is trying and has been trying for a number of years to get this telescope funded. And she was trained by Professor Harouni, and she's a radio engineer and radio astronomer herself.
Somebody should approach the Saudis. Maybe go appeal to MBS or something.
Raising money, unfortunately, is not my forte, so I haven't been able to contribute to this myself. But I'm just, of course, people need to know about these things because most people don't know of the existence of Harouni's antenna. I didn't know of the existence of it itself myself until maybe 3 years ago. So suppressed it has been. Now, Dr. Robitaille has been arguing for years from other points in endurance of the existence of Professor Harouni's antenna, that the so-called microwave background of the leftover from the Big Bang is actually due to radiation from the oceans of Earth, owing to the hydrogen bond in water.
Yeah, we're really excited to speak with him, and I think we're going to speak with him in a couple of weeks here. We're really excited to hear his story.
That will be a very interesting discussion with him. He's a very knowledgeable man and very capable scientist. And so the CMB does not exist. That's why it's never been measured beyond 900 kilometres of Earth, because the COBE satellite detected it in orbit around Earth at an altitude of approximately 900 kilometres. Now, out at L2, where the Planck satellite was located and the American NASA satellite WMAP was located, that's about 1.5 million kilometres from Earth. Now, the WMAP satellite was a differential instrument, so it was incapable of detecting the alleged cosmic microwave background monopole signal there. But the Planck satellite was able to do so. It had a capacity to do so, but it never reported detection. And the reason why is that it is not there. And so the radio signal from the cosmos left over from the Big Bang doesn't exist. Well, all of this comes from relativity again. But the theory of relativity itself is based on a mathematical flaw, which means that Einstein's theory of gravity and the universe is actually false. It's invalid. You cannot have a mathematical theory of the universe that's built upon a mathematical error. Well, and I've written this in my latest papers, where I show that Einstein's original presentation of his field equations for the gravitational field, he wrote in what is called unimodular coordinates. And using unimodular coordinates, you can rewrite his very same field equations in terms explicitly containing his so-called pseudotensor. Now, according to Einstein, these two equations are equivalent. Yes, well, he derives one from the other in a certain way, and I've explained this in the paper. However, I've shown that if you contract Einstein's pseudotensor, you get a first-order intrinsic differential invariant. And that's a mouthful, and it means that the invariant is constructed from the components of the metric tensor and their first derivatives and nothing else. However, the pure mathematicians, Giorgio Ricci-Cabastro and Tullio Levi-Civita, who are inventors of the tensor calculus, which this is involving, proved in 1901 that first-order intrinsic differential invariants do not exist. In other words, you cannot construct one. They do not exist in mathematics, and yet Einstein has a pseudotensor that produces a first-order intrinsic differential invariant, which tells you that his field equations are invalid. They are based upon a mathematical error. And so his whole field, his whole theory of the gravitational field and the structure of the universe, his mathematical equations are invalid. Now, that's not a difficult proof, but cosmologists are completely unaware of the fact that first-order intrinsic differential invariants do not exist. Why? Because they have not studied the literature. They do not know this mathematical proof, which was published originally in the French language.
What effect does this have on the rest of science? If the first-order tensor doesn't exist, what does this do?
Well, it just tells you that the whole theory of general relativity is invalid.
That's a pretty bold.
A whole lot of it. It's invalid.
That's a hard row to hoe right there.
Yes, but it's true, and everything that's been derived, therefore, from this theory is nonsensical. Big bangs, black holes. The black holes is a double whammy, because not only is it based on a theory with a mathematical flaw, the hole itself contains another mathematical flaw, and I've proven this by showing that you can construct. I have constructed an infinite set of equivalent solutions for the so-called black hole in its various forms, and this infinite set, as I said, is equivalent. Now, if any element of that infinite set cannot produce a black hole, then none of them can, because they are equivalent. Well, I can take an example, and I say, well, take this example from this infinite set, and you can see immediately that it cannot produce a black hole. Therefore, all those other solutions, which includes Hilbert's alleged solution, shows you that Hilbert's actually does not produce a black hole, because it is equivalent to all these others, an infinite set. And that infinite set is sound because they all satisfy Einstein's field equations and the boundary conditions. So mathematically, they are consistent. However, it shows you that the black hole is false. And why? Because in the black hole solutions, my proof shows that it is all based upon and can be reduced to the fact that the black hole solutions require that the absolute value of a real number take negative values. You cannot do that. The absolute value of a real number cannot take negative values. And yet they construct the internal area below their event horizon by ignorantly allowing that the absolute value of a real number takes negative values. So you can see that can't be true.
So there's no physical correspondence to that, in other words.
None at all. And that the equations for black holes are all false. So that's that problem. Then, of course, the black hole, or the theory from which they derive this equation, or these equations for black holes, are also based on another mathematical fallacy of Einstein with his pseudotensor, and he needs that because he wants to be able to satisfy the usual conservation laws of energy and momentum for a closed system. Without that, his theory cannot satisfy that physical reality that experiment has shown. And Einstein constructed it for that particular purpose. He wanted to conserve energy and momentum of a closed system. So he knew that was true, but to do it requires the production of a mathematical fallacy. That means the theory can't do it. And the mathematical fallacy shows that it's a nonsensical expression. So that whole theory is false. What about the special theory of relativity? Is that salvageable? The answer to that is no. And I've done this in a paper a couple of years ago. It's a very simple proof. According to Einstein, if you have an expanding sphere of light, you can explain it or you can describe it with an equation. X squared plus y squared plus z squared equals c squared times t squared, right? This is the equation of a sphere. And he uses this equation and transforms it under the Lorentz transformation, and he gets another equation, x prime squared plus y prime squared plus z prime squared equals c squared times t prime squared. And he says, well, look at that. They're the same equation. Therefore, one is the sphere, and it's transformed by the Lorentz transformation to another sphere. That is false. Let us reduce this to a very simple one. Instead of a sphere, we'll use a circle, because a circle's got fewer complications. And we can set, for instance, the speed of light to 1, just for convenience. And that means any speed is a proportion of that. So we'll take, well, the speed between these two systems of reference might be v is equal to 0.9. And for convenience, we'll set a time of 1 second. Then we transform 4 points, because after 1 second, that expanding circle of light centered on the origin, x, y of naught, has a radius of 1. And so the points 1, 0, 0, 1, minus 1, 0, and 0, minus 1 lie on the x and y axes, respectively, on that circle. So we take those 4 points and we put them into the Lorentz transformation. Do we get another circle? The answer is we get an ellipse. That means Einstein's argument that because the theorem of Pythagoras holds, that's because x squared plus y squared plus z squared equals c squared t squared is actually the equation of a right triangle in 3 dimensions. So it's the theorem of Pythagoras. Einstein mistakenly thought that because the theorem of Pythagoras is form invariant under Lorentz transformation, that the shape of his expanding sphere is also an expanding sphere under transformation. That is false, because the distance from the origin of a set of coordinates to any curve, no matter what its shape, is always given by the theorem of Pythagoras, right? X squared plus y squared plus z squared equals the distance from the origin to the curve. So claiming that under Lorentz transformation, the theorem of Pythagoras is form invariant, and that's fine because it's true. But claiming further that that means that the sphere that he had to start with is also a sphere in the other system is not true, because the 4 points that I just gave you, if you form them, you get an ellipse. That means his expanding sphere is transformed to an ellipse, and not only to an ellipse, but to a translated ellipse, so that the center of that ellipse is not located at the origin of coordinates. And that center is moving. So as time goes by, the center of that ellipse is moving away from the origin. Whereas in the circle that he started with, as the sphere or the circle gets larger, the center stays at the coordinate center x, y, naught. So this is a very simple proof that the special theory of relativity is invalid.
And is this fundamentally an error of treating time as a length-like dimension in the Pythagorean equation?
Yes, because that's the distance from the center of the expanding sphere to the circumference of that expanding sphere, or the surface of that expanding sphere. In the case of our circle, it's the distance from the origin of coordinates to the circumference of the expanding circle, right? So c times t is the radius. C squared times t squared is the square relating to the theorem of Pythagoras. X squared plus y squared plus z squared equals a radius squared, right? Or the hypotenusa of a right triangle, right? So that is always a right triangle. If you draw, for instance, an x value and a y value and find that point on that circle, the distance from the origin to that point on the circle is the hypotenusa of a right triangle. That's the theorem of Pythagoras. So now, if you do it with a sphere, it's still the theorem of Pythagoras, but the circle makes it easier. And so if you transform by points or you transform by equation, you had better get the exact same geometric form, because if you don't get by an equation the same curve that you would get by plotting points, then you've made a mistake. And that's what Einstein did. He didn't plot any points. He plotted an equation, and he thought, oh, this equation, which is actually the theorem of Pythagoras, and because he used that to construct a circle or a sphere to begin with, he thought that because it has the same form, it must be a circle or a sphere. No, it's not. Take any curve in space. Well, let's take the plane, the XY plane. Draw a curve. Now take the distance from the origin of coordinates to that point, any point on that curve. It's given by the distance squared is equal to x squared plus y squared. So you see that the shape is not maintained by the theorem of Pythagoras. The Pythagorean theorem maintains the distance from the origin to any point on that curve. So form invariance of the theorem of Pythagoras does not imply form invariance of the shape of any curve or surface. And Einstein made that mistake. If he plotted a couple of points, just like I gave you, those 4 points on that circle, does it produce a circle? No, it produces a translated ellipse. That means even though the equation of Pythagoras holds after transformation, the shape of the form does not. So Einstein's claim that an expanding sphere of light remains an expanding sphere of light under Lorentz transformation is false, and that is fatal to his whole theory of relativity. So the special theory is false, therefore the general theory is also false, without even having to go and look at his field equations. But remember at the start of our discussion, I told you that I worked backwards. I started with general relativity and worked backwards to special relativity from the black hole problem. So now to go forwards is very simple, but to go backwards and analyse all of this took many years and a great deal of my time and energy. But now with this simple proof, people need only now to plot a couple of points to see that Einstein's theory of special relativity is invalid, therefore the whole theory is invalid. The game is over.
What do you make of these sort of classical tests? It seems like every time I open up some Earth News channel, it's like a new confirmation of Einstein's theory, like the GPS or something like this. What do you make of these news headlines?
So let's take an example. According to Einstein's theory, in a strong gravitational field, clocks run slower, right? So that means on the surface of Earth, a clock runs slower than it does in orbit. Well, what about an hourglass? An hourglass is a chronometer. An hourglass is really important because it relates to gravity, and that's what Einstein's theory is all about, gravity. So we take an hourglass on Earth, and it's calibrated, so we know that it measures an hour if it all runs through. Now we take that hourglass on a spaceship and we put it into orbit around Earth. What happens to it?
Not much.
It stops. The whole thing stops. The hourglass doesn't work. There's no gravity. Well, there is gravity, but gravity is nullified by the fact that you're in orbit, and so you become weightless. So, but now we see that the clock has stopped. Our clock in this case is a hourglass, or you could use a pendulum, right? But did time stop? Does time stop for all the astronauts, for example, in the International Space Station? They take an hourglass with them and they say, oh, look, the hourglass has stopped. Yeah, it stops. But does time stop for them? Not at all.
So it all depends how you define time, basically. If it's what your clock does, then even perhaps you could imagine, even if you take one of these cesium atoms up far away from a big object, maybe it just won't be experiencing the same gravitational pressure anymore, and it'll be able to vibrate less impeded.
Yeah. So clocks, you see, can be affected by gravity. Clocks, but not time. Time is not affected by gravity. According to Einstein, time is affected by gravity. But no, it's not. Clocks can be affected by gravity. And not only this, the hourglass behaves in a way completely opposite to those who profess that the GPS verifies gravity by time.
How so?
So in other words, They're completely diametrically opposed, and yet they claim that the GPS verifies relativity. Well, I can say no. The hourglass proves that it's wrong.
How so? Sorry, I didn't follow.
In the gravitational field, according to Einstein, the strong gravitational field, the clock will be slower. And when it's away from a gravitational field, it will run faster.
Mm-hmm.
That's correct, right? Remember that gravity, of course, makes time slow down. Right? So it's running slower in the gravitational field. So on the surface of the Earth, it's actually slower, not faster.
Mm-hmm.
And you're saying, well, if you use this other clock, you can actually show that's not the case at all. It just depends what kind of clock you have.
The hourglass, as you now see, behaves in completely opposite to that of what Einstein says about time. And this comes back to how Einstein defined time. He defined time by clocks. But clocks don't define time. A clock is a measuring instrument, and it measures something outside itself. All measuring instruments that we invent are designed to measure something outside the instrument, right? So you cannot define what the instrument measures by the instrument. You have to have something outside the instrument, and you design the instrument to measure that. So Einstein defines time by his clocks. So whatever his clocks do, that's what he says time does, because his clocks tick and tock. Now, we've seen about calibration. If you have a clock that ticks and tocks at something, you don't have any other calibrator, they tick and tock at different rates. So take any clock, it's not calibrated, any clock, and according to Einstein, it ticks and tocks at different ways.
Mm-hmm.
Well, then you're not talking about time, you're talking about clocks. And he uses clocks to define time, and that is not true. Clocks do not measure clocks. Clocks measure time, and time is not what clocks are. A clock is not time. A pressure gauge, for instance, a pressure gauge measures pressure, right? But pressure is not defined by a pressure gauge. Time is not defined by a clock. In his 1905 paper, Einstein defined time by means of a clock. And by using clocks, he can make them tick and tock any way he likes, and therefore make time do anything he likes, because for him, time and clocks are no different. Whereas we see that time and clocks are different, as pressure and pressure gauges are different, as thermometers and temperature are different. You know, we're measuring things with an instrument to measure something other than itself. Einstein's clocks measure only themselves. Well, that's detached from physical reality. And that's the problem with his fundamental ideas of physics. This is not a physical theory. This is mysticism. And so it's not surprising that the mathematical apparatus to just try to substantiate this theory are all based on mathematical errors.
The clocks do run faster in space, though, right? That's what he was saying about GPS.
That's what he says.
But
clocks will clocks will run faster away from a gravitational field because clocks and time are the same thing for him. And so time now is running faster outside of gravitational or far from a gravitational strength, right, field. But close to in a strong gravitational field, time slows down. Why? Because clocks slow down. But we've now seen that a clock like a pendulum clock or an hourglass does exactly the opposite. And if you're in space as an astronaut with an hourglass or a pendulum clock, they stop, but time hasn't stopped for the astronaut.
I love the idea of an astronaut in space with a grandfather clock.
I think Steve's saying it's very similar to the situation with the gravitational waves. It's sort of like you're finding a clock that fits the model and you're using that one. Just
That's
like
right.
with these waves, you're finding the noise that fits you're looking at a ton of different models and then finding some noise that fits them.
But relativity is a predictive theory, right? Like this is why it's held for so long, which is that.
But the number of clocks you could come up with are kind of endless.
This is true.
It wouldn't work with an hourglass, which is what Steve's saying.
And how many experiments do you need to prove a theory wrong? Only one.
This is true as
No
well.
matter how many experiments you do, you can't prove a theory. But with one experiment, you can prove a theory wrong.
Mm-hmm.
Our little hourglass proves it wrong. Our little pendulum clock proves it wrong on physical grounds. Our mathematical analysis proves it wrong.
Water clock would prove it wrong.
A mathematical theory that's built on a mathematical fallacy is wrong. Now, here's a very interesting argument due to Bill Gaty. I spoke to Bill Gaty some years ago, and Bill's an interesting fellow, and we were talking about time dilation, and I said, well, yeah, it's all nonsensical because of these other relations. He said, well, here's one, the twins paradox. According to Einstein, you have a twin that stays on Earth, and then the other one travels at a very fast speed to a star far away at near the speed of light, turns around and comes back, and he finds that his brother or her sister, whether it's a man or woman or brother, or either one, are on Earth, and they find that the one on Earth is now a very old person, a very old man or woman, and the other one who travelled is very young still, hardly aged at all. Well, how can that happen? Oh, because of time dilation. Well, it comes back to Einstein's definition with his clocks. Now, what is a year? A year, we say a year is the execution of an Earth and Sun orbit, right? So once the Earth and the Sun, has executed one orbit, that is a year. Okay, now, let us measure our time for our travellers, not in seconds, but in years. So we have a year clock. Every tick is a year. So the twin on Earth stays on Earth, and the other one flies off to a far distant star near the speed of light and has this year clicking clock. Year clicking, ticking clock.
What a
So he brings an Earth and a Sun with him?
Well, no. So this is the argument that goes this. So now the traveller goes out to the star and comes back, and his year ticking clock has done, say, 2 years. And the one on Earth says, no, my years have gone, I've got 40 years have passed and you've got 2 years. How can that be? Well, that's time dilation. But as Bill Gaty points out, well, that means the one on Earth executed how many orbits of the Sun? And the other one says that the Earth executed how many orbits with the Sun? Only 2. And the one on Earth executed how many orbits of the Sun? 40. How can the Sun and Earth execute 2 different numbers of orbits? It's not possible. So in other words, this is a physical thing that's completely nonsensical. A year is the orbit of the Sun, the orbit of Earth and Sun, right? So you cannot have 2 different numbers of orbits of the Earth and Sun for 2 different observers simply because they're moving with respect to one another. That's nonsense. Now, that argument came from Bill Gaty, and I like that argument because it's very simple. And it doesn't require the mathematics that I've shown the theory to be wrong, but it does relate to the clocks of Einstein. You see, clocks and time are not the same, and confounding both of them for the one thing is not true. Otherwise, you don't need to worry about pressures. You just use a pressure gauge, and that defines pressure everywhere. It defines what pressure is. But what's pressure? Pressure is force over area.
By the same sort of rigor, what would you define time as?
Time, I just take time for I don't have any particular definition of time. I don't have theories. I just see that time is one of those things that philosophers have pored over for a long time, and Einstein made mystical with his silly theory, and now everybody's more confused about what time is. I just take it as something that is there. It's a kind of physical parameter of a physical being or physical reality that we experience, and we invent devices for measuring it. Just like space, it is there. We use measurement devices to measure the distance between A and B, and we measure times, and we measure other things. I just take them as our physical realities for our starting points, which comes back to our assumptions. What are the assumptions? I assume that there's a physical reality. The physical reality manifests in these effects. We don't know what they are, like Newton says. We don't know what causes it, but it is an effect. And we use things to develop or to measure things. And then we use some of these results to cobble them all together to give us theories, and use a bit of mathematics to help give us some more codification of these ideas, remembering, of course, that mathematics and physics are 2 different things.
And I think that that's the overall theme of everything that we've kind of covered in this conversation, right? It's that there is a world of pure mathematics and there's a world of physical objects. And it's very important as you travel through the world of mathematics to make sure that if you're attempting to speak of physical objects, that the things that you're saying actually make sense and they're not lost.
Correct. Absolutely right. Now, you even have physicists now telling us and telling the world at large who are interested in these subjects that the universe is actually just mathematics. No, it isn't. A stone is not mathematics. You put your hand on a hot iron and you burn yourself. That's not mathematics.
Yeah, I'd really love to talk to Max Tegmark. So if anyone knows Max Tegmark, I'd love to have a word with him.
Yes, well, he's the man I had in mind, actually, with his silly book that the universe is just mathematics. No, it isn't. It's physical reality. And Mr. Tegmark is involved with the cosmic microwave background and the generation of the anisotropy maps. As Dr. Robitaille has shown, those anisotropy maps have no meaning. They are nothing but noise. And they're due to violations across the board of imaging science. And you might also know that Dr. Robitaille is an expert in imaging science, being the inventor of ultra-high field MRI. He knows how to take a real image.
Yeah, it's going to be really fun to talk to him.
Yes, so that will be very interesting for yourselves and for your audience, I'm sure.
So this seems to sort of all boil down to mistaking the map for the territory kind of argument.
Yes.
Which is a sort of classic fallacy, if I'm not mistaken.
Yes. Here's an interesting thing with the anisotropies. George Smoot was in charge of the differential radiometers on the DMR, on the Kobe satellite. And he expected to get anisotropies from his alleged maps of the cosmos after removing the monopole and the dipole signals. And he says in his book that he puzzled over why he couldn't see the anisotropies in this, the so-called wrinkles in space-time. And he said, well, we decided that, well, let's remove the quadrupole. And he said, because we believed it exists. Well, he believes it exists. Okay, so he takes out the quadrupole. This is all image processing, right? So he takes out the quadrupole and all of a sudden he's got all his anisotropies. He says, look, we've now revealed all the anisotropies, but this is a systematic removal of noise from the maps. So as Dr. Robitaille pointed out, when Smoot removed systematically the quadrupole, he introduced systematic ghost signals, and he mistook that for data. Well, I once remarked facetiously that Mr. Smoot actually, when he removed the quadrupole, got all of these dots and he couldn't tell the difference between data and dots before his eyes or spots before his eyes. Well, the point is, of course, that that's what he did. He's got spots before his eyes and he thinks that that's data. But as Dr. Robitaille pointed out, that is not true. Removal of the quadrupole introduced residual ghost signals, and this is well known in imaging science. You can even generate an image of something by algorithm when you take the object out of the chamber.
And this is when they deleted the sort of galaxy from the image? Yeah.
Yes. Taking all of these sorts of things out.
And Smoot did Smoot get a Nobel Prize for this?
Yes, he shared a Nobel Prize for that. He and Mr. Mather. And now Smoot knows about this. And so does Mather. They've known about it for years, but they choose silence over the matter, and they will not engage Dr. Robitaille in any discussions because he has proven that their images are valueless. They're completely worthless to science.
Well, that's not a good way to make friends, probably.
Yeah, and that comes from a man who is really, truly a very great expert in imaging science. He knows imaging science. He knows an image.
I believe it.
And he still has the world's record for an MRI image. The 8 Tesla that he designed in supervised construction of still has the world's record for the quality of an MRI scanner image.
Hmm.
Yeah, I'm really stoked to talk to Pierre-Marie.
Me too. Well,
Yeah,
I think-
Steve, it's been really fun to talk to you. My
Well, thank you very much for inviting me. I've probably exhausted yourselves. We've been talking for quite a while, and but we did cover quite a few subjects, and I'm very happy that you invited me and that you can pass this on to your viewers and listeners.
It's our pleasure. Thank you so much.
Thank you very much for the invitation, and I look forward to your interview with Dr. Robitaille. It will be very stimulating.
Excellent. Thank you so much.
thanks, Steve. Talk to you
Thank
later.
you very much. Nice to talk to you. Bye-bye.
Bye.